Hi, everybody. I'm Barry Liden. I'm the Director of Public Policy for the USC Schaeffer Center for Health Policy and Economics. And I am joined here by Nobel Laureate Dr. Daniel McFadden, who is going to share with us a little bit of his journey. But before we get started, I want to start out with some basic kind of introductions. First of all, I want to say many thanks to our co-sponsors of this event. We've got the International Academy of Health Preference Research, the Prefer Experts Network, the International Health Economics Association Health Preference Research Special Interest Group, and the Erasmus Choice Modeling Center, all joining us here at USC Schaeffer Center for Health Policy and Economics in this webinar, a fireside chat with Dr. Dan McFadden. I want to do a special shout out to our friends Joreen Veldvik with IAHPR and Summer Ozdemir at Duke for helping support making this project and helping make sure that the stated preference community is aware of this event here. And I want to thank all of you for joining us today. Today's discussion will have an opportunity for you to submit questions. We want to have this interactive. The way to do that is you should have a Q&A button down at the bottom of your Zoom browser here. Please think about some questions as we're going through this discussion. I'll kick it off with a few questions for Dr. McFadden, and then we'll open it up at about 30 minutes into the meeting here to answer your questions. And I'll go through and I'll just pick those. I think you can upgrade questions. So if you see other people posting a question you like, give it a thumbs up, so we can kind of crowdsource those questions. With no further ado, we'll go ahead and get going. It's my great honor to welcome Nobel Laureate Dr. Daniel McFadden to our discussion today. Dr. McFadden was awarded the Nobel Prize in Economic Sciences in 2000 for his groundbreaking work developing methodologies for analyzing discrete choice, research that revolutionized how we understand individual decision-making. His pioneering econometric models have become foundational tools across multiple disciplines, and his contributions to health preference research have been particularly transformative in helping all of us understand how patients evaluate treatment options and healthcare decisions. As Presidential Professor of Health Economics at USC and Director of the Econometrics Laboratory at UC Berkeley, Dr. McFadden continues to advance our understanding of choice modeling and its applications to health policy. So it's truly an honor to have you with us today, Dr. McFadden. Thanks for joining us.
Pleasure to be here.
So I'm going to kick this off with a quick description for those who may not be experts like myself in econometrics. Can you give us a brief description of the work that you did that earned you the Nobel Prize?
Back in the beginning of the 1960s, economics quantitative work was pretty much limited to regression and the kind of data that government agencies provided at the market, at the market level. But a revolution was coming with the development of computers. You started to see individual data from surveys and the ability to collect information on what individuals were doing. And that created a need for tools to work with those kinds of data. Now, what I did in my work was to develop a practical tool for analyzing discrete choice data, and that's what the Nobel Committee picked out as worthy of their prize.
A lot of the people on this webinar, we have about 142 people in the room here, are familiar with the use of stated health preference research, but you didn't start in healthcare. For those who don't know the story, can you share a little bit behind the project you were working on that ultimately led to your development of the theory behind discrete choice? I think it had something to do with highways in California.
Well, I will do that. And the initial work neither involved health and the way it came about, and it wasn't really a deliberate pursuit of research. It was just by an accident. A bit of background. I came into economics from behavioral science, and then my work in behavioral science was primarily in social psychology, and I was familiar with the kinds of models and tools used to analyze experimental data. But I was hired as a development economist initially at the University of California, Berkeley, and I was working on growth models and topics like that. But a student came by in uh, 1964 named Phoebe Cunningham, who said, "I have data from the California Department of Transportation on the selection of route choices for new freeways, and I'm trying to understand what motivated them to pick one route versus another. Do you have any suggestions on how to analyze data like this?" Well, I went to the board and said, well, let me show you a model that I'm familiar with from psychology, uh, produced by the psychologist Duncan Luce, which is used to describe multinomial experimental responses, and maybe this would be adaptable to econometric use for your data. So I sketched out how to do this on the board, and at the time it seemed like a reasonable way to proceed. First of all, because I knew that this model was consistent with the idea of preference maximization. What it did was involve noise, stochastic preference maximization, which was something that the psychologists thought about going back to Thurstone and the idea of perceptual inaccuracies at a psychophysical level. So that was the background for this. Now the problem was that there was no program to do this, and in fact, that was a day when computers were brand new. The only way to do computing was to go to a university computer center and run a job overnight. So I set out to program this for Phoebe, but it took me a year to write the program and get it to work. By that time, she had finished her thesis and moved on. So I took this work and put it at the bottom of my research pile with the idea that perhaps somebody would find it useful someday and I would eventually get around to writing it up. So that was how it all started.
Well, it sounds like the answer to my next question is you had no idea. But did you have any idea that this was going to be a Nobel Prize winning theory or this
Uh,
foundation of it?
yeah. No, I didn't. I viewed this as just being a transfer of knowledge from one field to another. I didn't give it any particular importance. And it was only after colleagues had said, well, there are quite a few uses for this. Why don't you write it up? Why don't you work on it further? That I got interested in. And the specific event that motivated me to pursue it was I was asked by my economics friends, Bob Hall and Peter Diamond, to help them out on a project they were doing on analyzing travel demand data from travel surveys, and they were trying to explain transportation patterns. And they said, well, maybe your model would work better than the standard regression models we've been trying to use. So I signed on. I met a lot of skepticism and a lot of difficulty, in particular, selling any kind of a new method like this to people. But I persisted, and it turned out that uh, this was actually quite a good tool. It predicted well, and it was able to do policy analysis uh, pretty effectively. Um, its big advantages were that it was consistent with the dominant idea at the time, which was that people were preference maximizers. Um, and it was practical. So it wasn't easy, but it was practical. And that's what got it all started. And I began to see how it could be used for other problems than just transportation. And students came to me with ideas, and I encouraged them to do that. And I pursued it myself, pushed it myself. for almost a decade, I would say that I pushed this as something that was useful for economics and other fields in a variety of ways. And that uh, little campaign on my part was successful. It has become a rather dominant uh, way of dealing with discrete choice data in a variety of fields, health being one, but also that original model and its siblings are what appear in neural networks and a lot machine learning algorithms and a political forecast and credit rating and a variety of other applications.
So it sounds like you've observed the use of your theory and the model being adopted across multiple domains. Let's talk about health for a second. How do you see the development? I'd say my observation is that it first started in transportation. It evolved more in environment, and then more recently in health. More recently, meaning kind of like the early part of this century. Um, but have you seen, what are your observations in terms of its application in healthcare, or where do you think it could be most helpful in healthcare decision making?
Yes, let me just step back 1 second and say that what I realized as time went on was that while economics spent a lot of time discussing how much how many apples versus how many bananas you would buy, that some of the big decisions that you make in economics, like the career you pursue or whether you get married or not, how many kids you have, those are discrete events. And if you want to do economics broadly and apply our ideas to a lot of important economic behavior, you need to be able to handle these kinds of choices and be able to predict them, understand how they're affected by policy. I think that applies particularly in health, where uh, people do have to make a lot of decisions, not only patients, but also medical practitioners and designers of health systems. And it's very, very important to have uh, statistical tools that fit that situation. Now, there are a lot of health discrete outcome problems which are not necessarily driven by preference maximization, even if preference maximization is what primarily drives people. But there are quite a few, and things like deciding whether or not to undergo a particular medical procedure or not that a patient makes, you might uh, uh, expect that to be driven by the kinds of motivations that describe other economic decisions.
And do you find that that's the case? In other words, can you use a discrete choice experiment to help a person make a decision about their preferences, or is the DCE more of something that helps make population level decisions for, let's say, policy decision makers?
I would say that it's primarily been used, and I think its most valuable use is to understand how policies affect people and communicate to people what their environment implies for their own benefit. For example, a lot of my health research has dealt with people's choice of insurance programs, particularly in the Medicare Part D program. And there, I think what's been important is one, to understand how those plans are structured and how they are communicated to people, influence the choices they actually make, whether um, policies like automatic rollover are fully beneficial, or whether they need to be modified in some way to get people to pay more attention to what's good for them. Those are important issues. I think these techniques have been used at the individual level, but uh, a caution here, which is that despite the fact that these models operate off individual data, it is actually a rather large step to make them directly applicable to any idiosyncratic individual as opposed to understanding something about the population.
How do you feel the field has evolved? Are there any developments that are particularly surprised you or excited you over the last few decades?
Well, the big development that I guess did surprise me, although I shouldn't have been very surprised, and I was kind of present at its early development, was the developments in cognitive psychology and behavioral economics that were not uh, came later than the initial work. The initial work in discrete choice was motivated by the kind of data and computational resources you had, and the idea that if people are rational in their choices, that tells you something about the kinds of models you should be building. Uh, what happened about a decade after I started that work was the first big major breakthroughs in cognitive psychology and eventually in behavioral economics. I met Amos Tversky and Danny Kahneman in 1972, and we had a pretty steady communication back and forth ever since. And their findings were resonated with some of the work that I'd seen back in my days as a social psychologist and doing running experiments. But I would say I never expected these behavioral effects to be as powerful or pervasive as they've turned out to be. Now, so I would say that the big change from the initial proposition is that while people may and probably do uh, pursue their self-interest, economic environments basically train people to do that because it punishes them if they're not uh, reasonably consistent in pursuing self-interest. Uh, but I think we found that people do deviate fairly often and in very substantial ways from the idea of a rather simple-minded, uh, static view of self-interest. In particular, there are a phenomena that's called the hedonic treadmill or uh, endowment effect, which says that people responses to any suggestion of change are very and strongly influenced by the change itself and of deviations from their status quo. And so that if when you look at people's responses in the market or in stated preference surveys or experiments, what you find are very strong effects like a big difference between willingness to accept and willingness to pay. And that turns out to be more than just a nuisance in survey research. It's a deeply deep feature of the way our brains are wired and how we process uh, choice information and make decisions.
That actually probably goes, I think, in alignment with a question that's come in from Reed Johnson, who I think you know. Behavioral economics has challenged the fundamental proposition that people maximize utility. Does that undermine the validity of conventional choice modeling?
The answer is it doesn't undermine its validity, but it con confronts it with some major challenges. There is an element of self-interest in people's choices. There has to be, but the data that we collect on people's choices and their patterns of choice reflect quite a bit of what I would call cognitive noise or cognitive factors other than self-interest that come into play and create a veil between what might be the underlying uh, drivers of self-interest and the answers we actually see. The model, such as the original discrete choice model that I developed and the variants of it, uh, taken literally, uh, tend to force you to concentrate on self-interest and ignore some of these other problems, and that turns out to not to be a good idea. Uh, so I think that other uh, cognitive features of choice do need to be considered. Uh, I will say this, I think that these classes of models viewed as statistical techniques and learning techniques have flexibility and capacity to handle lots of cognitive effects, even if they're rather complicated. One further comment on the whole behavioral revolution, which is that when we make choices, when we consider any change, there's uncertainty. At some level, there's always uncertainty about whether the change will be exactly what we expect it to be. And that's the hedonic treadmill, the idea that people are always skeptical of change, I think is a reflection of uh, how they respond to this uncertainty and a real aversion to being placed in uncertain situations. So that uh, what's I think become important in understanding discrete choice phenomena is to pay a great deal more attention to how responses are influenced by uncertainty and by some of the cognitive limitations that people have, such as um, a limited ability to be totally aware and on top of every choice they make.
Yeah, that's in alignment with a couple of questions that have come in. Let me read one from Benjamin Craig. Given the rise of big data, we have seen the move beyond traditional count analysis toward more stepwise analyses. Likewise, discrete choices can increasingly be decomposed into distinct cognitive and contextual processes. But in complex domains like healthcare, where decisions often involve multiple stakeholders, role expectations, and heuristic shortcuts, do you see game theoretic approaches as a more appropriate framework for modeling such interactive decision-making dynamics? Where should we go?
I think the multiple person decision is a very interesting phenomenon. I think a game theory of that is an appropriate starting point. Uh, I would say that some of the cognitive issues that arise in individual choice behavior are definitely present in games as well. And so one needs to think about the behavioral theory of games. This takes me way back to uh, the days in the social psychology lab when I was running repeated prisoner's dilemma experiments and um, studying the suggestibility of people in groups decision making when there were shills uh, suggesting fake information. Uh, and at that time, it was clear that uh, individual cognition is easily molded by one's social environment and social pressures. So these phenomena are, I'm not surprised that they're present, but I would say that the science of how to deal with that and how to do game theoretic models with social consideration, social interaction is still in its infancy, and uh, I'm sorry I'm not young enough to be an active participant in it, and I think it's one of the areas that will be very interesting in the next 20, 40 years.
So, do you think that there's room or a role for machine learning or AI to help facilitate or maybe even replace some aspects of the discrete choice experiment, or trying to determine discrete choice?
Uh, well, let me say a little bit about the history of this subject because I think that machine learning, while the language is often new, is actually part of the historical evolution of this field. Let me go back to when I first started working on this. Essentially, what I was able to do back in the early 60s was at the frontier of what computation would allow at the time. And the model, the original model I developed was basically at that time what pretty much at the frontier what you could hope to compute and use as a practical model. Since then, this whole field of discrete choice analysis and the study of decision making has evolved more or less in parallel with the evolution of computational capacity and the kind of data collection that's allowed by having good and better computation. So that you went from original rather simple multiple intelligent models to various kinds of nested models, which turned out to be somewhat more flexible, and to what's called mixed logit models, where uh, there are parametric higher or deeper level parametric distributions on some of the parameters, and those turn out to be very flexible models. They were initially not it was considered, but not used at all because they were completely impractical in the early computational days. And around between 1900 and 1990 and 2000, they began to become computationally practical. Today, I would say the mixed logit model is kind of almost the standard model for doing discrete choice applications. Now, you asked about machine learning and all that. If you think of some of the most effective machine learning techniques we have, such as random forest and a special area called causal random forest, and you look at how they actually operate when you get down into the weeds and look at how they build trees in their random forest, uh, those are often using elements that are the same as the elements that went into the original discrete choice models. That is to say, these are not really differences or alternatives to choice theory. They are just the evolution of choice theory to handle or to take advantage of the increased computing power and algorithms that we have available. So, what's true is that if you take data, let's say, for example, you look at the effects of drug side effects, one of the projects that I've pursued at Schaeffer, we're using random forests to do that kind of work. Those forests are not necessarily consistent with discrete choice models. Uh, and there's a reason you wouldn't want to limit yourself to discrete choice models, but they can be consistent. And that's actually extremely useful because you can then determine whether the kind of stabilities in the stabilities and invariances that are the property of rational discrete choice models actually work here, and if they don't, you learn something, and if they do, you learn something. So I would say that uh, I you I don't think of machine learning and these new techniques as being a somehow a challenge or or a difference. There's a little problem with the language and the fact that some of the data people have reinvent these things without realizing that they've been done before. But in terms of the science of it, I think it's just part of the natural evolution, and it's where discrete choice analysis and scientific approaches to these problems and stated preference analysis need to live.
So another question from the audience here, Matt Richardson asks, many discrete choice experiments involve survey tools, yet it seems that people are starting to get tired of answering surveys as they seem to be multiplying exponentially, the surveys, not the people. Do you see this as a threat to the discrete choice method?
Absolutely, there's absolutely a threat to survey research, which is that well, on one hand, it's become very easy to do um, uh, surveys and very easy to recruit people on the internet to take surveys. And so you see it being done all the time. You see it being done by um, people who are perhaps not well versed in the potential flaws of survey research. Uh, and so you get a lot of you get first of all you get the burden on people, and they're unwilling to sign up for these things. But you also get a lot of survey responses which are not subject to the kind of careful vetting and pilot studies that characterized surveys back in the day when you only had one chance to do it, and you really needed to try to make sure that the survey was understandable and people were answering the question that you were asking rather than something else. Uh, I think the particularly the use of recruitment techniques on internet surveys, which are fairly casual, are a real danger to survey research. In terms of choice theory and the use of uh, these methods tend to be as good as the data they get. So if you don't not getting good data, you're going to the data is not reproducible and not reliable, you're going to get results out of these choice models, which are also not reproducible and not reliable, and that's potentially a problem. It's a very difficult for humans, and I should say also for machines, to tell the difference between good data and bad data. And so, if survey research is cannot be curated to limit itself to good data, it becomes part of the problem.
I'm going to change it up a little bit here, going back to the mixed logit model. They've been a popular way to model preference heterogeneity. Do you see opportunities or needs for new types of models in light of emerging data structures or decision contexts?
I think one of the things that came up fairly early in the development of cognitive psychology was the idea that people, even if they have self-interest and are pursuing self-interest, they do a lot of filtering. Uh, and so what happens is that if I'm going out to buy a new car or a new house, um, before I don't try to do some kind of systematic data collection on every possible alternative in my potential choice set. What I do is I do certain kinds of filterings or screenings to limit myself to having to dig into only the more promising alternatives. Uh, and Filtering involves phenomena that are, I think, conceptually different than simple preference maximization. They involve some kind of way of processing uncertainty, dealing with uncertainty, and making, I would call them Bayesian judgments on what's worth pursuing and what's not. And I think the real challenge, one of the big challenges for discrete choice modeling is to understand that what seems to be the very important role of uncertainty in how we go about thinking about whether we have a choice, what the choice alternatives are, what we should be looking at in terms of evaluating those alternatives, and the extent to which um, those filters uh, aid or interfere with our final realization of our attempt to uh, match our self-interest. The machine learning techniques, in particular, often use filtering techniques themselves. You could think of random tree construction or random forest as a method of filtering, and it's very much like a model that Amos Tversky suggested back in the mid 60s called elimination by aspects, in which said in that model, you look at a few features, like if you're going to buy a house, how many bedrooms, depending, you screen on. I have kids, so I only want a house with three or more bedrooms. That's a filter, and understanding how we set up those filters and how you can model that filtering process and the kind of thresholds and discrete sort of nonlinearities in response that filters create, I think is an important new area.
There's a couple of questions that's helpful. There's a couple of questions that come in that might be similar. I'm going to try to kind of combine them. One of them is from Christine, who asked, since patients are often involved in shared decision-making models, meaning they're sitting down with a physician or unfortunately, so maybe a pharmacist or maybe even a payer. What do you think about running random utility models with patients, physicians, nurses, pharmacists, like multiple stakeholders in the model? And then the Kareen also has a question that might be similar, which is what is the advantage of machine learning models? One of the advantages is that they can handle multiple types of data simultaneously. What type of data do you think would be best to enhance that discrete choice data? Maybe those two are not related, but that's how I read the two. So
That's a tough question because I don't really have I can't go to the board and write down a practical model for describing those interactions. Let me just say something about the original motivation in some of this work, which was that uh, when I responded to Phoebe Cottingham's original request for how to analyze her data, one of the things I had in mind was that freeway route decisions were being made by some kind of committees uh, set up by the Department of Transportation. And so uh, the results that came out, the routes that get selected were the result of some kind of majority voting or the interactions between members of those committees. And one of my ideas was that, well, what will happen is that you have a committee, you typically will have a dominant person or a person who kind of sort of takes the stage and leads the committee decisions. And so what you're seeing are outcomes of the result of the sort of the winning dictator for an hour in a committee. But those positions change from one choice situation to the next. So that was my original thinking about how those models came about, and this notion of, well, you have decisions being made by uh, doctors, patients, and pharmacy benefit managers in some combination. Is that is it appropriate to apply that old idea that in the end someone just steps up and takes over? And the answer is probably not. Uh, it's probably more complicated than that, although perhaps it is worth thinking about whether the patient is the final decision maker. In a sense, they are, but they're making those decisions on the basis of possibly distorted information and certainly imperfectly understood information that they're getting from other agents in the health decision making process. So maybe part of it would be to understand how the final decision maker, if it is the patient, uh, uh, can understand and process the information they get from other agents like their doctor.
Kind of bummed that we don't have a whiteboard for you to go up to. We might have had just another Nobel Prize in the making of this question. So what advice would you give? There's one of the organizations that's a co-host of this is the International Academy of Health Preference Researchers, and one of its missions is to help grow and support the development of new researchers in the stated health preferences field. So what advice would you give to early career researchers working on stated preference methods today, particularly those who are focused on health applications?
I would say that the generic recommendation is that you need to immerse yourself in the subject matter. So if you want to explain uh, doctor and patient decisions, you really have to talk to a lot of doctors and a lot of patients and understand how these people's minds work. But more specifically, or I'd say more generally, uh, for someone working in these areas, I would say that it's important to get beyond the simplest entry points of survey research uh, and statistical analysis and um, achieve a sufficient level of sophistication in both survey research, survey methods, so that you can be critical. You can be critical of your own work and you can be critical of what other people do and understand when something may not be working right. I think one of the areas that's particularly important for health, but it's important, I think, now for all study of decision making, are the developments in brain science. And behavioral economics. Uh, when I started early in my career, biology was a very quiet field. Mostly spent its time classifying insects, but now I would say it's fundamental to understanding human behavior and understanding how the brain works, how our wiring works is very important. And so I would say that. Everyone working in these areas should do some background training, if not courses, read at least some of the uh, expository books about these things and understand how people actually react cognitively when they're confronted with the kind of tasks we ask them to do or ask them about.
Yeah, you remind me of a situation where I had both a quantitative discrete choice experiment data experiment and research outcomes, and then also qualitative interviews with the same patients at the same group. And I shared them with a researcher, and I thought they'd be mostly interested in the quantitative data, but really talking to patients and getting down and listening to them and understanding what's going on behind their decision making. I think you're right, can be really impactful in terms of interpreting what's going on in terms of why it is that they may be deciding going in a certain direction, and can help evolve the surveys going forward, which is almost the opposite direction of where some of the questions are that are coming in, which are, I think people are very interested in how can we leverage machine learning more. So I'm going to have one more question on this front. Philippe asked, following up on the discussion about machine learning and choice modeling versus traditional discrete choice models. The traditional approach relies on a structural utility function, that allows us to interpret preferences through model coefficients. But if that functional form is misspecified, the results can be misleading. In contrast, modern machine learning approaches often avoid strict functional assumptions and focus on predictive accuracy. In your view, what remains the core strength or value of the traditional discrete choice framework in this evolving landscape?
The big distinction between predictive accuracy as objective in analyzing data and some of the earlier ideas on choice modeling are that you look for invariances in behavior. The importance of invariances is that if you take the model to a different situation, it'll actually predict accurately in an basically out of sample situation. Now, when you look at predictive accuracy in using machine learning techniques, modern machine learning techniques already uh, are concerned with the issue of overfitting and fitting to too narrow a situation, so that it's not going to be predictive out of sample. And so cross validation and various sampling techniques are extremely important within machine learning, and they are improvements over some of the older ideas of using holdout samples and things like that.
Right, thanks. The next question is from Michael Hurd. Decision making under uncertainty seems to lead to not deciding. I can totally relate to that. That lack of decision likely contributed to behavioral explanations for the outcome, that is, the lack of a decision. But perhaps we should be looking at what people understand about uncertainty and the probability distributions of important stochastic elements of the environment. Could that focus help reconcile behavioral and traditional utility maximization?
I think the uncertainty operates in a variety of ways cognitively, and I think where we pay attention and what we choose to ignore in terms of how we evaluate situations is a very important element in decision making. And so I think we do need to get beyond the idea that, well, some decisions are more certain than others, and people have some expectations about what's going to come out, and um, we maybe have simple models of how they form expectations. We need to get into serious models of how our expectations are formed, how they're modified by the information we receive, and basically the extent to which in expectation formation as well as in choice, um, we engage in various kinds of protective behaviors, which tend to be rather conservative. We don't make choices, we don't make changes, we don't change our expectations, even in the presence of some information that might uh, rationally be desirable to process for that purpose. And we need this is part of the idea that we're rather simple organisms operating in a complex world, and our attention is primarily on whether a tiger is going to come up behind us and bite us or not. And there are lots of other things that we put aside and don't pay much attention to. So I think we do need to understand a great deal more about how uncertainty is handled, how it influences us, and how we process it.
That's helpful. I'm definitely at a lot of uncertainty in my decision making. I wish I could figure out how to deal with it better, but I think you're right that the simplest way for me is just to focus on a heuristic that I understand and can easily follow. So you've been in a lot of different domains in decision making. What do you think is the most important um, in as we in health choice modelers could learn from other domains of application like transportation or marketing or environmental economics and vice versa? Do you see any maybe complexities or simplicities or I don't know what between the different areas or domains that could be helpful to each other somehow?
Well, I think that there's a great deal from in cognitive psychology, and that includes specifically the Tversky-Kahneman tradition and behavioral economics, but well beyond that as well. That is useful to bring in front of you when you go about thinking about studying health decisions. And we just talked about uncertainty. I think the role of uncertainty is particularly important in decisions that are not rote decisions for us, decisions that involve new elements, things we haven't thought about much before, that our preferences, if we have them, are not very well expressed or even understood ourselves. And that's absolutely a description of the kinds of health decisions we often face. I mean, you yeah, when you encounter your first stroke, you have not had any previous experience of that, and you have a lot of uncertainty about how it affects you. So uh, things like treatment decisions, like are I think really important to understand the cognition and to take a broader view than the simple view that uh, people are just utility maximizers. There's an important element of self-interest, but there's a lot else going on too.
Yeah, I think you touched on something that the US FDA has really been sticklers on, and that is that in trying to assess patient preferences, it's important to ensure that you're asking people who've had experience with that particular condition and or treatment, because as you mentioned, the learned experience of going through it, you may have a different perspective over time. Do you think that extensions to discrete choice models accounting for insights from behavioral science, deviations from standard utility maximization need to be different from stated preferences compared to revealed preferences? So the hypothetical choice tax versus actual activity.
I would say that first of all, stated preferences and revealed preferences are often not exactly the same, and the reason is primarily that it's almost impossible to create in a laboratory or a survey the kind of the cognitive frame that you have when you go into a doctor's office and have to confront your diagnosis, uh, and so that uh, it's actually quite important, I think, to understand how those elements affect us.
Okay, well, we only have a couple more minutes left, and there's a few more questions. So I'm going to end with kind of a wrap up question, and that is if you were starting your career today, what kinds of research questions or methodological innovations would you be most interested in pursuing?
Well, I think the insights from cognitive psychology and neurology suggests that a lot of at least some of the problems that we encounter in working with practical decision problems and what people do uh, can be traced back and explained by fundamentals of the brain. And so I would say that uh, these days it would be a good idea for everyone to have some skills in cognitive psychology and brain science. Uh, if I were starting over, I think that's probably where I would have spent more of my studies.
Great. Well, thank you so much, Dr. McFadden, for joining us today for this fireside chat. The fire between us, I think we've got about 3,000 miles, but it's really great to have the opportunity. It's an honor to spend some time with you and to hear about your career and everything that you've gone through to help us all in the world of trying to help in decision making. For those of you who joined us today, thank you very much for your questions and appreciate your participation in this and look forward to further engagement. Thanks.
Yes, thank you all for your time.